All right, everyone, welcome to the next virtual vRetreat. We are starting up with Snapt, and then we will move on later on to Datrium. Today we have Dave Blakey. He is the CEO, main man in charge at Snapt, and he is here to present to you. So, Dave, if you'd like to give us a bit of a rundown of yourself, what you do, where you're from, and everything about Snapt.
Yeah, absolutely. And thank you. And thanks, everyone. Nice to see and chat. Oh, I've lost you all now that I've shared my screen. Let me expand that. Nice to see everyone in chat. Looking forward to it. So my name is Dave Blakey, for anyone who missed that, and I am the CEO of Snapt and primarily in charge of product and new product, which is specifically what this today is. I'm kind of here because we have launched a new product called Nova about a month ago. It went into public availability. And we're quite excited about it, excited to have people use it, get feedback on it. And that's why I've also included, you'll see my personal email on this slide. It's really because if anyone does have anything they want to reach out, communicate with about if you try the product, what your feelings are, whatever, please don't be shy. I think it's a great opportunity to get some real feedback and input from everyone. Now the company, as you can see on the top left, is Snapt. And Snapt is an ADC company, Application Delivery Control. That's familiar to some, might be less familiar to others. It's really load balancing plus, right? So the old days of load balancing, you would have traffic coming in, you need to distribute that load to online servers, so the fastest servers. It started to grow from there. Let's also consider things like security and performance and all of the various things that ADC kind of became. And that's our focus. We've been around for about 7 years, and we've had a software ADC that focuses on the more traditional markets, north-south traffic, competes with the likes of F5, Citrix, people like that. Our new product is much more focused on east-west and multi-location load balancing. It's targeted more towards DevOps users and to people with kind of mixed stacks when you look at things from a per app level as opposed to per environment level. And that's what I'm going to take you through. So my plan is to give you a bit of background about it, why we made it, what it does, what it's good at, where it should be used, etc., and then just show it to you. Go through it, talk about how we use it, how we see our clients using it, on what platforms, how they run it, etc., and then answer any questions, etc. And then finally, there is a community edition, so anyone who wants to play with it can, but we also have NFR licenses, so if you guys want the kind of full feature pack or whatever, we can arrange whatever is needed to do that, pretty much. So, Nova. Nova allows you to deploy, scale, securely manage, and observe any number of ADCs across multiple locations and environments, right? This is what we're going to have a look at. And this is where the kind of foundation of the product really kicks off, and that's that ADC, when we began, 8 years ago, and for the longest time, for 20 years, has been a per environment activity, right? So in the old days, you would have a rack in a data center somewhere, and you would have a load balancer or an ADC in that environment, and everything that you needed to be serviced by that ADC. And this led to things having to be built around the load balancer and everything having to conform, and that's just not the way things are done today, right? Like in your, firstly, you're not sitting in a rack a lot of the time. Secondly, you're not sitting in one location a lot of the time, right? You'll be in multiple data centers on multiple different vendors, could be some public cloud, some VMware on-premise, some hosted VMware, some vCloud. It could be a whole mixture of things, and it almost always is. And secondly, it's a whole mixture of applications that all have their own requirements, right? Per application ADC as opposed to per environment. And that's really what we focus on. We focus on the per app requirements, regardless of where it is, how it might be deployed, or where it might be tomorrow, right? Flexibility and kind of the ability to move and change it. So ADC is 4 core functionalities. Most people are aware of this, but I don't really feel like it accurately represents what it is in today's market. So traditionally, it's a load balancer, a web accelerator, an application firewall, and a method for getting telemetry about your traffic, right? So, what are the response times on HTTP? What's the network latency? All of that kind of stuff. These really boil down to 4 needs that the application architect, solution engineer, or IT operations center have, right? Which is the availability, performance, security, and observability of their applications. And this, I think, is in more demand today than ever before, basically, right? Especially when we start to look at multi-location and microservice-based apps, right? Where you've got many services sitting across multiple different stacks or in multiple different countries or locations interacting with each other. The observability of that is critical, right? Tracing and diagnosing things. The security of them is harder than ever with multiple endpoints and this explosion of endpoints and APIs and microservices that's going on. And the availability and performance of them is, of course, as much of a concern as it's ever been. Now, per environment ADC historically does not solve this problem well. It's not customizable by app. It's very difficult to move. You suffer from things like vendor lock-in, for example. If you often, we see clients that have a situation where they say, well, we've got a hardware ADC in our data center. We use ALB and Amazon, and now we need a solution for Azure. Or we're now hosting, we've moved our data center, we've got a new VMware set up somewhere, and we want to host in VMware and in AWS. And the solutions just don't fit in both locations, right? Well, you can use ALB there, you can use this kind of vendor lock-in becomes a big problem in this space. And that's one major limitation. And then the second limitation is that you really need lightweight kind of worker ADCs as opposed to high compute, high feature ADCs that sit in a north-south environment when you move to east-west, right? We used to, by way of example, when we started, a big deal for us would be 10 ADCs. That was a really big client, right? Meant they had 5 data centers around the world, a lot of traffic going through them. So, it would be active, passive. Now we have clients that have got, I think our biggest is 460 ADCs in one organization. And you can imagine why that leads to it. That describes a very different type of application architecture, but also means that you need a very different way of managing that number of ADCs, right? That amount, that size of system. It's all over the world. It's in multiple stacks. Some's in VMware, some's in public cloud. They're in every continent. They have multiple endpoints that need different security rules depending on where they are or what applications are behind them. And it becomes almost impossible to make a change across all of them in any kind of sensible or auditable way, right? So this has led us to kind of suggest that ADC 2.0 is needed. This re-envisioning of what ADC gives, whilst still having these 4 critical components, right? Availability, performance, security, and observability for your application. But really deployed and delivered in a very different way than your traditional north-south load balancing has been. And the first concept of this ADC 2.0 is that what we're describing when we talk about ADC is a service and not a server. So because of how it was deployed, the realities of it, right? It used to be a rack server. You'd stick a 2U system in your rack somewhere. They've long been thought of as services, as servers, where really they should be thought of as services. So when you say something like, okay, accept port 80 traffic, redirect that to port 443. So we're going to switch from HTTP to HTTPS. Then I want you to decrypt that traffic, secure it. So don't allow things like SQL injections or denial of service attacks or cross-site scripting through. Cache whatever you can, see if we can reply with that, compress it, optimize it, etc. And then if you need to, send the traffic to this set of web servers that are described in such a way. Really, to me, that's a service. It's not a server, right? You're describing how you want to interact and how you want things to get to your app. And it should function as a service as well, because it should be able to be deployed in wherever you want, however you want. By example, if you have a production cluster sitting in your VMware stack at your data center or on-premise, wherever it might be, there's no reason why your developers should not be able to deploy those same configurations on their local tests, or why your CI/CD environment should not be able to run that same ADC, and you can pick up if the WAF's going to block some component of your API. But because of the way things have been designed, that's never been possible, right? So really the concept of having it as a service is very important. It also speaks to the reliability of it, right? And the statelessness of it. So when it's in the data plane, when it's actually running on a VM or in a container or whatever it might be, it should be stateless. You should be able to lose it and not lose anything. You should be able to scale it out or up or scale it in or down, right? You should be able to reduce the number of VMs that it's using or increase the number of VMs that it's running on, etc. And the only way to achieve that is with a control plane, data plane layout. So what you're going to see is that we have a central control plane where you orchestrate all of this. You configure your ADCs, you see your statistics, you deploy them, you set them up, you create new ones, things like that. And then you ultimately deploy that to the data plane. But what you're deploying are lightweight worker ADCs. So they're extremely compute efficient, right? You can do about 150,000 new connections per second on a single vCPU on a VMware cluster, right? So one core, 2 gig of memory, 150,000 connections per second, or 15,000 SSL transactions per second. Very high performance compared to what's typically available. In the past, that would be like, 8 to 12 cores. And when you're looking at a client that's got 450 of these things running in production, needing 12 cores per instance is a problem. So that's the second thing. Then ADC needs to be everywhere, right? So I've hinted to this already, but you should be able to deploy it on your VMware stack. You should be able to deploy it into your containers. You should be able to deploy it to your public cloud environments, and all the way down to your developer's Vagrant box, or in your CI/CD environment. It should be able to exist absolutely everywhere. And then in order to cope with the massive amount of ADCs and infrastructure and endpoints and traffic that we already see, the network should be able to drive itself as best as is possible. As often as is possible, the network should drive itself, right? So what we mean by that is that it should be resilient. It should self-repair. For example, if a system dies, it should automatically rebuild it. If it needs to scale out, it should. If it can scale in, it should. If it needs to alert because of some kind of threat or traffic pattern, if it needs to take action because of an anomaly, whatever it can do in order to really enable the operator and the platform architect and the DevOps engineers, it should automate as much of itself as it can. And so that typically starts with things like anomaly detection and pattern matching, stuff like that on the nodes, up to things like ML and AI on the cloud itself, where it's looking, for sequences or anomalies or things like that across many nodes at the same time, which we'll have a look at in a bit. So how does this often look? So it's just kind of one of our diagrams, but it's an example of how different things are deployed today, right? And when you think of your simple example where you've got 2 web servers and a load balancer sitting in front of them versus today where in reality, you're probably on multiple cloud providers, on multiple data centers, multiple stacks, right? You could be in multiple countries within each of those stacks. This is very common. So we see this at like mid-size enterprises. It's no longer just a case of large-size businesses. And even small startups will be in multiple countries to try to get closer to their clients as people move workloads closer to the edge. People are in every state in the US, etc. And you have a situation where you need to route traffic not just to a data center somewhere in the world, but then also within that data center, you need to understand, what routing rules are applying. Is this going to cluster A, B, C? What service does it need to go to? If there's a service degradation there, where's the nearest data center it can move to? What's the quality of service you need to account for? And this stuff could shift all the time. We've got a lot of clients that will move workloads from one data center to another based on the time of day, based on the pricing that they have, all of these kinds of things, or they'll be doing a feature update and they'll shift most of their West Coast traffic to the East Coast. Like these are the realities of ADC today, right? It's a much more complicated thing than a north-south load balancer was. So Nova provides a centrally managed, scalable, multi-platform, per app or per environment ADC for companies who want flexibility to avoid lock-in, to enable next-gen deployment methodologies like east-west traffic, like cloud native, like service mesh, and to scale the apps across multiple locations and platforms, right? We do this on a DevOps-friendly, SaaS-based, easy-to-use platform, and that's what we're going to have a look at. So the next step is to show it to you. What I'm going to show you, I'm going to switch my screen now. And like I said, there is actually a community edition of this. So we allow people to deploy up to 5 load balancers for free. But also we will have NFR codes and resources available, for the full kind of feature stack, etc. Just swapping screens now. Cool. Okay, so you should be seeing my browser now. This is the dashboard. This is the website, shall I say, where you log in. I'm going to log in here, and you'll see it will take me to my dashboard. Now, this is just my account. And what you see on the dashboard is a summary of kind of what's going on. You can see I've got two ADCs here, Snap Partner and Snap Shop. We're going to create a new one, obviously. We've got to look at kind of what our app profile is like, any recent notifications, where our nodes exist, and so on. But basically just kind of a summary page. And then under organization, obviously this is, who's got access, what's the billing, what subscription do we have, and things like that. But then the first kind of key differential, the most important thing I think really about the system is nodes. And this is where it all kind of begins, right? A node is a system that is running the Nova client. Now, the Nova client is a thin client that can be installed on basically any platform. I'll show you that in a second. And what it does is connects out to the Nova cloud and establishes a two-way connection through which we can then control that system. So in reality, what is a node, right? It's a container, a VM, a cloud instance, or a hardware device. That's basically what a node is. So it's a single instance. Like in a VMware environment, it would be one VM. And you can have as many nodes as you want, right? So if I was to create a node, let's say manual node, I can create that manually. And here you see an ID and a key, right? This information is then used on the node where you install it in your own tenant. So when I say it's deployed to the cloud, I mean it's your own cloud account or your own VMware situation, whatever you've got going on. And that ID and key will lock that node to your account. So you can see here, there's VM images. So you've got, the various platforms that you might want. You can install it wherever you need. You can install it on an existing Ubuntu system. You've got a Docker image. You can use a Helm chart if you're installing Kubernetes or any kind of, Kubernetes-based orchestration platform. You've got your Docker image, you've got your Linux client, etc. So it can really run anywhere. And what's nice about it is that everything is tied to this node. So if you would then link that ID and key elsewhere, if you moved clusters, if you moved to another platform, whatever you did, if you had to rebuild your VM, you just link that ID and key to another node and it will immediately swap everything over. I'm going to delete this one because I don't want to do a manual installation. One of the things you can do, entirely optionally, obviously, is link your provider platforms, right? So you'll see here, I've got a bunch of public clouds. What you can also do is coming out in 11 days, next month, is that you can link to VCD, so vCloud. So you can actually integrate with people's like custom kind of cloud components, but these are public clouds we've got here. And you can see, DigitalOcean, EC2, GCP, whatever, etc., Azure, and so on. And what this lets you do is two things primarily. So if I go into my Test DigitalOcean account here, it lets you firstly see the systems that are running in that environment, right? Endpoints here. We see them. So in our example here, what I'm going to try and set up is just load balancing for a couple of web servers. So you can see here we've got New York Web Server 1, Web Server 2, San Francisco Web Server 1 and 2. And if I was to go to one of those IPs, we see, snapped hello. Now, the reason that it does this is because things are not static anymore, right? So the number of servers that you run are no longer static and their IPs are no longer static. So like by example, we could have our DevOps team launch more web servers in San Francisco, or our VM could fail and we could rebuild it on another system, or it could move over to another stack or whatever it might be, and the IPs might change. And so you want to send your traffic to your origin servers, your web servers, in a way that's not static. You don't want to be forced to do it statically, right? So for example, on this DigitalOcean account, we might want to say, use the tag web servers. So don't use IP addresses, but look at the tag web servers. Another example is if you're auto-scaling a system, right? You might say, okay, well, this system can run on anywhere between 1 and 10 VMs. And depending on load, it could run more. So if it does scale up, we need to know that, and we need to point the traffic to however many systems are online. And so that's what this is all about. And then the second thing is that it'll let you deploy. That's what I want to do. I'm going to use this to get a working node up and running so that we can use it. So you can actually spin up new systems. So here, for example, I'll say auto node. And we can say we'll put it in New York where these two are. And we'll use the cheap ones, and we can just say launch 2. So what this is going to do is provision 2 new Nova nodes that we will then ultimately be able to deploy ADCs to, right? They'll be our load balancers for our web servers. And it will connect them and set them all up and do everything for us. So you'll remember it's exactly the same as adding a manual one, where you can then install anywhere, except that this is just provisioning the actual equipment for me as well. So this takes probably about 30 to 60 seconds at most, and then they'll be online and we can actually use them. So that's what you're seeing here, is just that kind of deployment process. But this is also great when you look at auto scaling your actual service. So like I mentioned to you, when you want to deploy a service instead of a server, you can, instead of saying, okay, launch 2 instances, or I want 2 VMs, you can say, okay, well, I want between 2 and 50 VMs, or 2 and 10, or whatever it is in this environment, and it should run this ADC and it should just scale automatically. So whatever.
Dave,
yes,
I have a question from Chris Lewis.
Jump in.
Yeah, Chris says, is there an API to do this programmatically?
Yes, absolutely. And there's a bunch of docs on that. So I've just middle-clicked the docs button, which takes me to the cloud one. But you can see here, there's an API where you can see it's just a REST API. You get a bearer token, and you can automate all of this basically. So you can set it up all automatically, create new nodes, provision them, or anything you might want to do. So while I was on the other page, the launch completed, so they're up and running, so we can actually use these things now. So if I come back here and look at the nodes, you'll see we've got 2 new ones, Auto Node 0 and Auto Node 1. They're collecting their initial data still, but they're online and good to go. So the next thing you want to do when you're setting up an ADC is create the backends. So backends are where we're going to send the data, where it's ultimately going to go, right? And those are your upstreams, your origin servers. So in our example, they're the web servers that our website sits on. They could be anything, right? But for us, it's going to be the web servers. And you can do a simple backend, which is what kind of the typical in the industry will be, obviously. And that's that you want to put in IP addresses and ports where you want to send the traffic to. So you've got however many IPs and ports as you want to set up here, and it will then send the traffic there. You can later configure a load balancing algorithm, like how we split it all up, but here it will also take into consideration your weights and things like that if you want. So you can configure it just like that, or like I was mentioning, there's a lot of non-static options, right? So here, let's say we do here example backend, just give it a basic name. You can say simple, like I suggested, or we could do DNS result, right? So we might have a name server that we want to look up a DNS address on, and we want to use whatever IP it gives back. And what's nice about that is that you could say, okay, well, I want to look at this specific name server, and I want to cache that result as valid for 5 seconds, but every 5 seconds look it up again. And if there's more service, send it to more. If there's less, send it to less. It's very flexible, right, from that point of view. You've got your service discovery, which is great if you need to send things into something that supports some kind of service discovery environment, right? So Kubernetes, Console, Docker Swarm, Rancher, a lot of VMware stuff supports service discovery like this. So, you want to use named services, and it can hint all the way down to like the ports that they want to use, the weights that they should have, all of that kind of stuff, which it does with SRV records, right? Then you've got redirects, which, is just if you want to redirect traffic simply, basically. And then you've got Cloud API, which is what I want to use for this, because we've launched these systems in the DigitalOcean cloud. So if I submit here, you'll see we say we're going to send the traffic to port 443, right? It's a website. So we're going to send it to HTTPS. And then instead of putting in IPs, we'll link to that platform connection, and we'll use the tag web servers. Now, if I update this, it will automatically keep that in sync for us. So if I come in here, you see we've got 4 IPs and 4 ports, and that's going to just manage that for us. If one of them was to fail and be rebuilt, if the IP changes, it'll pick that up. If our like DevOps automation engineers launch a whole bunch more, or shuts them down, or whatever might happen, it'll just keep it in sync for us. So we know that if we use example backend, it'll go to anything that's tagged as web service. And you could do that on an AMI ID, you could do it on an image, it can link into basically any platform, or you could use a simple one, and to that question that got asked earlier, and update that simple one just with one REST API post. So you can integrate it very easily into your tooling. And what's nice is when you update that backend with an API post, it will then update all of the nodes that this backend is being used on, which you'll see in a sec. So if I now come to ADCs, this will be the part that's familiar to people that are familiar with load balancers and ADCs. But I can create a new one here, and we're going to say example website, SSL termination. There's a bunch of options here though. So you've got like HTTP, HTTPS pass-through, remote desktop. We're doing a lot of that nowadays, let me tell you. Exchange, TCP, so you can load balance anything you want. But obviously SSL termination has the most functionality by far, and it's the most complicated. So we'll set that up. And then I submit. This creates an ADC for us. And here you can see the stuff you kind of expect to see, right? How do we load balance this system, right? What do we do for session persistence? What SSL certificates? Yeah.
Question, are you able to use multi-cloud providers, meaning if I need to expand into Azure, AWS for duration and connect in conjunction with my on-prem infrastructure?
Yeah, that's exactly what you can do. So that's the perfect example. Is that like people have got workloads that burst to cloud now, or they're in cloud just for multi-location situations, all of that kind of stuff. So when we deploy this ADC, you'll see, but you'll be able to deploy it into many locations. And so one could be your VMware stack on premise, one could be in Amazon, and one could be in Azure, and you can manage it in that way. So that's exactly right. That's actually probably to be kind of candid with you guys, the lowest hanging fruit for us, the like hottest opportunity is multi-location systems, when people have their apps running in multiple places and on multiple stacks, not just like US East and US West AWS, but when they have multiple different vendors at play, it's really good for us. So we'll set this up basically with the defaults. One nice thing that I like to mention is that you can actually provision Let's Encrypt certificates directly from this ADC. So, it will issue your certificates, renew them for you, manage all of that kind of stuff for you, which, like I say, when you've got 450 ADCs with hundreds of endpoints on, can be super useful. But to be honest with you, most of the bigger clients use their own certificates. And then I'll use our wildcard certificate here. So it's just a snapped wildcard. It's our actual one, but it's not going to work. It's going to give us an SSL error when I go to it via the IP address, of course, but that doesn't matter. And then we'll set up our backends. So here we choose our example backend and say we want to send traffic there, right? That's our web service group, but it could be many backends as well. So we could say, okay, well, hang on. We want to send the traffic there if it's partner.snap.net, and otherwise send it here by default, etc. And you can do this with as many as you want. You can switch this to ACL groups, so you can actually have a huge list of things that gets into a specific location, whatever you want to do. But in our example, we're just going to say, okay, everything's going to example backend, right? Because that's just where we want to send the traffic. You have health and protocols, how we check that they're working, that they stay online, and all of that kind of stuff, how often we check. You can pass NTLM data through. And then this is quite an interesting feature, which we actually see quite a lot of use with in bigger clients. And that's that you can stream logs directly from a Nova node to your own syslog server, which is great for things like, central security monitors, visibility platforms, all that kind of stuff, shipping logs off site if you've got a system that you need to, like for fiduciary reasons, keep logs of, or whatever it might be. So you can configure that all. And then your performance and security. This is the real kind of bulk of the ADC. Your limits, so it's basic stuff like maximum connections and connections per second. But then, do you want to cache and compress? So we can turn that on. SSL will redirect HTTP, HTTPS. Other thing you'll notice here is it's quite easy to configure, right? So we try to make it very easy to use and practical. And, the API is the same for this, right? These all have just documented fields, and you can just post this as an API request. We will re-encrypt because it's public cloud and we're using port 443. So we'll re-encrypt the data. And then security is kind of the next good stopping point. So I'll
Your
turn these on.
question quickly from Hussein is on Docker, if the container died, does it restart by itself? Also, how does it store the logs for audit purpose?
Yeah, so with Docker is a good example. So if it's a Docker container running on its own, what's nice about this is that it assumes no state from the node. So as it reconnects for the first time, we will check anytime it's been disconnected, right? We will check what configuration it has running on it and reestablish it to whatever configuration it should be running. So if, for example, like you're sitting in somewhere like Kubernetes, right, and it relaunches a container, that container will come back with no configuration potentially if it doesn't have persistent storage. It can have, but it doesn't have to have. And as it connects, we will then put this entire ADC back down onto it. So it creates, when I attach this ADC, it creates a permanent connection between this ADC and that node. And then anything that identifies itself as that node will always run the configuration. Logging is a great question. And it's actually an example as well, where in the old days and still today, you had so much data and value sitting in the data plane, right? So like your actual ADC sitting there in your rack had not only all your configurations on it, but also all your logs, your WAF blocks, your information that you needed, etc. And a loss of that meant a loss of data. So you had to provide backups and stuff like that. And even then, like now we say, if you've got 450 ADCs and someone wipes out all of them, how long is it going to take to get them back? And usually the answer is quite a long time. We store everything centrally, right? So your performance metrics, your WAF blocks, all of that kind of critical information is stored centrally, not on the node, so that information can be lost. You can destroy a node and rebuild it at any time, and you don't lose anything. And then the access logs, like I was saying, you would stream that off to some kind of security information manager or like a storage system. Like, we've got clients that will accumulate all of their logs, and then they put that in something like Redshift or somewhere, like a data lake, basically. Now on security, you can see I've turned on the WAF, which we'll actually have a look at just now. So that's your layer 7 WAF rules, like your OWAF top 10, SQL injections, cross-site scripting, DOS, all that kind of stuff. And then also your various protections. So what's nice about these is that they're quite common in the ADC market, some of them. Like post protection is very common. And what that does is limit the number of post requests per second that someone can send to a system. And the way it does that is just by kind of evaluating it and having a limit. Sometimes it's a burst window and then a limit, but still it will be something like saying, allow 1 request per second, or 10 requests and then 1 per second, or something like that. And it doesn't really work that well in modern environments where you could have, a whole bunch of users coming from one IP, or you could have that this system is behind something like Akamai or Cloudflare and it sees all of the IPs as being one, all these kinds of et cetera, et cetera, et cetera. What's nice about these features is that they work off of the anomaly detection engine on the node, right? So they look for abnormal patterns in these various areas. So like to detect an abnormal pattern of posts, for example, you might say on a normal website that always, when someone logs in, when they send a post request to login, they've always at least downloaded some style sheets, some images, they've sent a GET request for the login page first, or they've gotten an error on that page if their password didn't work. Like this is what the profile of their traffic looks like, right? If someone sends 20 login requests without ever having requested the content that's on the login page, it's super suspicious, right? You could say, okay, well, what about an API? But it will profile that. It will say, okay, well, these people send posts all the time. And this is what they look like, and this is how often we expect to get them. So maybe on an API, it will block people if they do, 50 requests a second because everybody else is doing 5, or however it might work, but it's adaptive, right? So like scanner protection is a good example as well. What that'll do is say, okay, someone is running a vulnerability scan against a site. How do we tell that? Because the first thing a vulnerability scan does is request a whole bunch of URLs that don't exist, right? It's got like 100,000 URLs, like /wp-admin for WordPress and phpMyAdmin and .git and .config.backup and all these URLs it tries to hit, and we will monitor what comes back from the web servers as well. So we see, okay, this web server is generating like 20 404s, 20 page not founds per second for this user. That's an anomaly. Let's block it, etc. So, and we'll see some of that just now. And so the way it kind of handles that is tries to be very automated because, again, like I mentioned, we need to cater both for the person who has one node, but also for the person that has 1,000. And then you've got your basic stuff like blacklists, where you can block things. You've got your header manipulation. You've got geofencing. So this is quite cool. You can do a default to allow. I want to allow everyone to do everything, but I don't want to allow, what do we pick? Ecuador and Nigeria, right, are going to get blocked. So we'll allow everyone through except for them. By contrast, you could say, okay, I want to deny everyone, but allow Egypt only, and you can configure this as much as you want. So that will then apply on all of your nodes as well. But let's assume that I've configured this and everything, and I've set it up and I've saved it. We've got a backend and we've got an ADC now. So essentially, we've got a fully functional ADC. And this is where the biggest difference with Nova becomes even more apparent, although I can tell from the questions it's already apparent, obviously. But that is that this is not actually running anywhere. So what we've configured here is the service, right? The description of how this ADC should function, not an actual ADC in the way people typically think of it, which is a system sitting in a rack somewhere or a VM that's actually running. It's not connected to anything. It's an intent template that we can then attach. So if I deploy this now, I can deploy it to any number of nodes I want, in any location I want, and in multiple locations and in multiple ways. Like, so here you can see this is an autoscaler that we actually use. So that's an undeterminate number of nodes that might be running. And over here, we've got our 2 auto nodes that we launched. And like I say, they could be anywhere, right? They could be, like, it's very common for us to have a situation where we're deploying to both VMware and public cloud, or to 2 different VMware stacks, or whatever it might be. And if I attach this, we'll see that it will now create this link between that configuration and those nodes. Now, the first time we do it takes about 15 seconds. Let's see if I can guess it. It's often 12 seconds, but we'll see. And then after that, it takes 2 seconds to apply changes. So it's very quick. When I talk about apply changes, what I mean is, like, you guys saw me select a certificate, right? So I said, well, I wanted to use the Snapt wildcard certificate. Let's say we change that. We update our certificate. Then every single node in your environments around the world that uses that certificate will get the new one. By the same token, if we were to send an API request, like I was saying, that changes the IP addresses of a backend, any nodes using that backend will get the new one. And so it maintains this kind of link.
Dave, we got quite a array of questions coming over the last few minutes.
Cool.
So
let's hit them.
Yeah, let's hit. I mean, yeah, I thought I'd try and choose a point where you're going into this. But Christopher Lewis says, how does this compare to the NSX AV Advanced Load Balancer?
Sorry, to what?
How does this compare to the NSX Advanced Load Balancer?
Yeah, so in a couple of ways. NSX is coming quite a long way, to be honest. So the load balance is quite good now, I think, for most of your kind of typical use cases. Where it's not ideal, obviously, is when you do have multi-location load balancing and you want to manage it centrally, as well as where you want things like application acceleration and application firewalling, right? Now, we'll also mention that, interestingly, VMware has recently acquired probably our closest competitor, a company called AVI. That's why I wasn't sure. I heard you say AV, and then I thought.
Yeah, it is RV. He's just missed the I out. Yeah. Sorry.
Yeah. But so they are actually looking to increase some of their offerings in that space, and I think that they're going to become probably our biggest competitor. Where we find our way and where we kind of have a space is that we focus very much on per app. And very much per service, right? So like, a microservices type of layout, east-west, might need different types of load balancing, different WAF policies and different security groups and performance configurations at large in kind of like a service mesh. And they may also need to be deployed to Amazon and to Azure and maybe to like native Amazon containers and, environments where you can't necessarily plug in VMware. So I think like the flexibility, one of the big trends we're seeing, and I don't have the best word for it, but it's this kind of like this fear of vendor lock-in, right? So obviously with a product like ours, you've got a lot more functionality than you do when you use the platform providers solutions, right? So there's a lot of things, tweaks, features, settings, like the ML components and some of the visibility and stuff that those platforms don't have. But sometimes you don't need that stuff. But what you do need is flexibility, right? Like the ability to not be stuck in AWS if you need to move to Azure, or if you need to be in multiple locations, or if your VMware infrastructure also needs to run in public cloud, or all of these kinds of concerns. I think make it quite difficult to decide to use the platform provider solutions all of the time.
Yeah. Okay. There's a massive influx of questions coming at the moment. If you take a look at the chat. Next one. What about whiteboards? Gareth says. Whitelists. Sorry, not whiteboards.
Whitelists. Yeah, absolutely.
Sorry, I
You
misread
can.
that.
So you can whitelist in a couple of ways. You can alter our application firewall rule sets. So you can do things like say, I don't want to block on that and I don't want to block on this. You can also have it learn. So you can say, okay, well, that very specific thing that you block, just allow that, right? So you're not disabling a rule, but you're saying, all right, well, if you find like these SQL keywords in this URL posted in this way and that piece, then whitelist that. Or you can whitelist entire IPs if you want. So you can configure that. And the nice thing again is when you whitelist an IP, you can whitelist it across all of your nodes if you want. And then when you delete that whitelisted IP, it's deleted. So like management is a big problem of this type of solution. When you've got 450 nodes, let's say we have a whitelisted IP. It's the bank, right? The bank's external IP is whitelisted, and so it's allowed to do a lot more stuff than anyone else would do on 450 nodes around the world. And the bank's IP changes. Like, what are the chances if you're using 3 different or 4 different load balancing providers in different places? Some of them are build your own, like HA proxy, some of it is NSX, some of it's Azure, some of it's Amazon's ALB, that we can be sure that that IP is removed all over the place. Right? It's very slim. Like it's very difficult to do this type of orchestration management and then to verify that. So yeah, that's exactly like that type of functionality. That's really nice to centrally control.
Yeah, and also, I guess around that, Mark's question of dashboard view for performance metrics and stuff like that. You've obviously got that included.
I'm about to go there right now. Yeah.
Yeah. So I mean, there's quite a few ones on here. I don't know whether you want to just go down for the list and see where there's and go through them, because it's probably going to be easier than be going into all of them, because some of them might be more relevant to things you're coming up on.
Yeah, so I think, so there's a billing question. I've just popped it open now. So in terms of billing, if this was deployed solely to an Azure environment, for example, can that be built through Azure? No, you would subscribe on our platform. So for the free version, obviously you wouldn't have to pay anything, but if you did pay, you would put your information into the organization billing page here. We do actually have Azure Marketplace images where we could do that, but because you might want to pay for like extra data retention on our platform or things like that, basically the billing is on platform right now. Let's see, what is this site? Okay. Ingress controller integration for Kubernetes. Yes, absolutely. So that's exactly, you can deploy it as a container. So if you want like a service mesh type thing where it sits on the side of your application services and manages that, or you can also have it function as an ingress controller. The dashboard we're going to have a look at. And let's just see here the expansion on the whitelist question. So, satisfying for loads of requests, for example, other security software, vulnerabilities in your software behind this. Or for example, you're running other security stuff. Yeah, so you can do exactly that. Like, so you can whitelist, like we actually have to whitelist often because one of the things it does is detect vulnerability scanners and block them, but you really don't want to do that if you're actually running a vulnerability scan, right? So there are a number of ways of whitelisting and things like that. But yeah, let's look at the stats though. So basically we've deployed the system now. So you can see this ADC is actually running on 2 nodes, right? So I deployed it to 2. It could be 10, it could be 100, it could be 1,000. That's another thing that's important with this platform, is it's extremely scalable. So, I mean, I don't know how scalable it actually is because currently our testing capacity caps out at 1.2 million nodes. So we're only able to run 1.2 million nodes against the system right now, but that's the maximum capability that we have. Obviously, that's an unreasonable capacity in today's world, but as service mesh and containers take off, we actually think that there will be organizations around the world that have situations like that. But we should be able to go to this website now, right? If I find one of the IPs of one of those nodes, So like I can come here to see, here's this New York one that we launched in the States, and we can take that IP and go there. And we should get an SSL error because of the snap.net certificate. So I can accept that, and then we should see that same web page. It's being load balanced now, right? So we can come here and see this ADC's data now, and we can see that it's had requests now. So if I come look here, you can see that this one, I've sent 4 requests to. That's the amount of data that went through, and we can actually monitor that live here, right? So as I was to send traffic here and browse through it and all that kind of stuff, it will show on the dashboard. And more specifically, if I was to send a bad request, like let's say I ask for etc password, right? Good way to get a WAF to block you. You'll see that I get blocked. So you can see we're starting to monitor the response time, the number of blocks, and we can come in here and look at that and see, okay, 8 seconds ago, my IP address requested etc password in the argument test. I mean, that's a pretty basic one, but you could have something legitimate where, you're working on a table called users, perhaps, which is totally fine. And then you say, okay, well, delete from users, something like that. Obviously gets blocked as well, right? And if we look here again, you'll see that it's picked up my SQL UDF injection, right, in the string. So it's blocked that for that reason. And this is just a live view of that system. So it's got very little traffic right now, but you can see that we're seeing the 2 nodes, right? So if I was to send traffic to the second one, let's find out its IP address, this IP. We'll get the same block because of the SSL certificate, and we can just accept that. And then we'll see the same page. And if it refreshes every 10 seconds, but if I just refresh, you can see that we've got more requests now. So we can actually see them, and we can go all the way into the node if we want. So you can see here, looking at this node, we sent the traffic to the first server. 2 milliseconds it's taken it to reply. Took a while to send the traffic back to me, obviously. 5 successful replies, 2 404s, which are this favorite icon that doesn't exist. And we can go all the way in and see actually which IPs are requesting these, right? So interestingly, this is my IP here, but this is someone else's. So probably just like a scanner, or this is a web server version checker or whatever running along. But you can see what's going on there and what traffic's going through, and you can monitor this all live. You can see, here you get the live graphs, here you get response graphs and all of that. But there's much more information available. So if I was to come into one that's actually running, I don't know if Nova Vision is enabled on this. Let me just check. But in the meantime, we can look at the telemetry. So you can see here, like, what's our response times? How many connections per second are we getting? What's the throughput? The request rates, like we can see big spikes in the reply times, like around deployments that we do, where it has to optimize the system and so on. Yes, it is running. And then we can go all the way into the HTTP data, right? So here we're looking at 278 entries. The site doesn't get much traffic, this partner site. And we're saying that there were 4, excuse me. The mute button, what a good feature. We're saying that mostly we've had successful, we've had a couple 400 errors, no 500 errors. What content types have been requested, what servers are serving them. You can see downloads at snap.net and partner.snap.net. What are our slowest URLs, right? Like, so what takes the longest time to load, our most unreliable URLs, top error URLs, and you can go all the way into these, right? So like, if instead of this one, if I look at our example website, I can say I want to look at the logs. Now, if you were looking for my IP in a bunch of logs, you can imagine how difficult it can become, right? But you can just search for it here, and it will show you always my data, right? Logs from me across however many ADCs you have. So if you have 450, you see one stream, and you can stream this live via the API as well. We can switch it to a styled view where you see like a bit more detail. And there you can see like this is a cache request, like there's my blocked one that MySQL deletes, right? But you can see it all kind of come streaming through. And if I was to do something like, say, question mark live log equals hello guys, like that. And when we come here, we'll see that. So there's the image in there, live log equals hello guys. So you can see like for tracing, diagnosing, monitoring, it's very easy to get like live data, and you don't have to go like squirreling through all of your ADCs, like if some are in AWS and some are in VMware and some are here and some are there, it's quite hard to track them all down, right? So it's really great to have that kind of all centralized, especially with like WAF blocks and stuff. So when we look at like historic WAF blocks, we can see, well, where have they happened, right? So like these are our examples here, but here you can see like this was blacklisted because it's a known spammer, and DOS limit that it hits. Restricted file access attempt. That's a good one, right? .env, database /.env. Someone tried to access and it's obviously blocked that request and so on. So you get the idea. And there's a huge amount of stats. I can't really go through everything right now, every piece of it, but you get all of this kind of stuff as well. So you've got like your global app performance, right? Like what's your response times, your connect times, like is there network latency? Like here you can see we had a spike of network latency. So if I turn off these, because that's a share, hang on, that's the percentage. Let me turn off this and then we can see like there was an increase there in the latency. How many requests, where have there been errors, all of that kind of stuff, your IOPS, like your success and errors, your number of HTTP replies for all of your nodes, and so on. And the other thing that's really nice about Nova nodes is that for any of you that are familiar with the kind of the Prometheus Grafana stack and monitoring things like that, they expose Prometheus endpoints. So you can actually scrape them for like raw data that you can then process in your system, analyze however you want if you don't want to ship logs off, and so on. Now, the other thing that I've been showing you is obviously the WAF. So with your WAF, you've got a whole bunch of options. You can, do your normal type of stuff. Do you have, like we have a WordPress site, so we've enabled those rules. Your HTTP blacklist, a Project Honeypot blacklist, like Project Honeypot, if anyone's not familiar, is like a cool honeypot service where they pick up like spammers and comment harvesters and stuff like that.
Hang on a sec, Dave. I've got a couple of questions on the chat there. Just gone in. Cool. I think he's saying, can we authenticate the users from AD and roll out permissions for level 2 guys?
So we don't do user authentication yet on the people coming through. If you mean the actual traffic flowing through the system, like we don't do user authentication on the HTTP requests. It is something that's coming soon. So it's coming down the line. Soon is maybe a bit of a stretch, probably like 6 months time, to be honest with you. But with logging into the dashboard itself, you can integrate with several kind of login providers to give people access to the interface itself to use. Yeah, more Grafana fun. Exactly. But I mean, yeah, the fact that it can expose so many metrics from Prometheus is really nice, because you can then kind of build your own and integrate with your own. One of the biggest trends that we've seen, so I mean, you guys can probably tell this is quite targeted at what you might describe as DevOps users. And they really often have their own stacks and want to integrate with their own stacks and features and things. So we try to be as open as possible, like open APIs, exporting data, giving them access to things, etc., so that we can fit in the environment. And then under the WAF, you've also got the threat center. So you can see kind of an overview of your system, right? Where are your risks? Have we blocked any hosts? Have we black holed hosts? So black holed hosts would be like a distributed denial of service attack that's being mitigated. A given Nova node can stop about 4 million packets per second, and you can run many of them, obviously. Where's our throughput coming from? So you can see here a bunch of places in Europe we've got some throughput, mostly the US. This is just our account. No risk because the AI hasn't picked up anything, but if it had, you would see, potential threats. So that's like looking for things like obviously your traditional DOS attack, but also like an unusual amount of WAF blocks from a net block in China, or, that North America is sending far more negative requests than it normally does, and, whatever might get profiled, right? And then your rates by country, DOS by country.
I just saw, sorry, just scrolled down. Sorry, Chris, I didn't see, Christopher, I didn't see yours at the bottom. It says, wait, what about VROps and RBAC, sorry.
Sorry, let me just check the chat. We don't, so yeah, you can integrate with pretty much any monitoring platform if you're willing to do some work and tooling. Everything else is kind of on our to-do list, so we're trying to support as much as possible. But basically, you can request metric information using just direct HTTP endpoints. So you can actually just like fetch the information from this location, and you can send information to your stack using webhooks, or using what was I going to say, webhooks, or by streaming syslogs to that system. So if it's something that we don't support, then you can do that. Right now, we only support natively Prometheus and then on dashboard kind of reporting. Yeah. But like that kind of thing is quite important for us to know, like what people are using these stacks. Is like the market, like as a bit of an aside, to be candid with you guys, quite hard to understand like really what one thing that I've learned recently is that every client we seem to get to has got kind of their own stack built and their own, this, they like this is how they look, these are the environments and stuff. So, working out like what to prioritize and where to put things is a challenge for us. It's something that we're working on the whole time. So yeah, you've got your kind of threat center here. And then the last piece that I want to show you, there's obviously like 1,000 features. I mean, you can see how many things I'm not even kind of going into here and, various options and stuff like that. But the last thing is destinations. One of the most difficult things to set up properly for kind of medium-sized enterprises is a proper GSLB system. So GSLB, for anyone who doesn't understand, is a global server load balancer. And what it is basically is a smart DNS server. So when someone goes to www.snapt.net, it doesn't just reply with the IP addresses of snap.net, but rather it bases that reply on a set of rules, i.e., are these IPs online? So is where I think that this user should go for this DNS request currently responding to HTTPS traffic. Also, where is the closest data center to this user maybe? So for example, I could say, well, send Europeans to Europe, but if Europe's offline, then send them to the East Coast of the US, etc. Right? And they will normally have to run that themselves and manage it themselves, and it's quite complicated. And then also you need tooling to update things when your IPs change and all that kind of stuff. So destinations is an on-platform version of GSLB that users can use. And you'll see if I was to say like our demo dot my organization name, so that's Snap for me, .novadestinations.com. This will actually provision a fully qualified domain name that we can use, and it will route that traffic to our 2 nodes. So one of the questions that's come up in this chat is, like when nodes change, when we delete them, when we move them, whatever. If you were to move auto node 0 to another data center or another VMware stack somewhere else, the GSLB destinations will automatically pick that up and update the traffic as soon as it's back online. You can do health checking, you can do nearest location routing, etc. But if I just save that, what it will do is provision this for us, right? So now we could use like a CNAME or an alias or whatever to point our website's domain to that, and we'll know that it will go to our online nodes, and then we can easily kind of change and update that and whatever. So if I was to open that in a new tab, you can see we get the same certificate error, obviously, but we can then proceed and we get the same site, right? So this is now online being managed by us, handled by us, and you get stats for it with us, right? So like if I look at this one, for example, you can see some of the statistics and throughput, like we get 63,000 queries per day on this site, etc. And you can see the address that we were using for it. So this is actually for our shop. And you can see the traffic and stuff, and this all gets fed into like anomaly detection, DOS protection. So like we know, for example, the number of DNS queries you get versus the amount of traffic you get as a typical profile. Very typical to see with the DOS attack that you get far more traffic than you do DNS.
So Mark's asked, with more telephony moving to SIP, can Nova nodes manage / monitor SIP?
No, right now there's basically a blunt reason why we can't. Right now, so we have 2 product lines, Aria and Nova. Nova is this cloud-operated, centralized kind of cloud-native version. Aria is our more traditional north-south one. Only Aria supports UDP traffic. And SIP obviously depends on UDP traffic. That same engine for UDP is coming to Nova. It's just not there yet. So Nova almost exclusively is used for HTTP traffic. And that doesn't necessarily mean websites, but it means like APIs, service mesh, all that kind of stuff. But yes, we are. I don't know if you saw when I created an ADC that it says DNS is coming soon. And that's because UDP support is coming soon, which will also enable SIP. So no, not today.
Sure, but it's on the list.
Yeah, exactly. I saw another question, is it JSON? Yes, exactly. It's JSON. So interestingly enough, Influx, I'm interested that you use that. I don't know if you saw the telemetry page where I showed that the time series data. We actually use Influx. So yeah, absolutely you can.
Yeah, and Christopher Lewis has asked on the API stuff, is there a Terraform provider?
Not yet. We're busy implementing that stuff. Like, so we launched Nova publicly, I think just over a month ago. And like the Helm chart, for example, we've only recently integrated. Terraform we are working on. So, you know, as you can see, we already support stuff like console. You know, we are working with the HashiCorp guys, etc., and stuff like that, and supporting it all. Right now, HashiCorp, Red Hat, and Helm are the first three things we're working on. And then the other two integrations, interestingly, is what's that APM thing? Oh, how can I not remember that now? Like the biggest one, New Relic, and another one like that that we're busy adding support for. But so yeah, we're constantly doing that. Yeah, Terraform is a great point because it really speaks to what this platform is about, right? Which is that, you know, you want automation, you want tooling, you want scale, and all that kind of stuff. But I hope I haven't steered too far away from the idea that it's also great for one ADC. You know, one of the kind of key things that we've been trying to do is to say, well, you know, like I said, you can have 5 nodes for free on this with the community edition, is to say, you know, how can we get this in people's hands, get feedback, all that kind of stuff. So we are working with Tanzu a lot. Obviously, the you know, VMware's announcement recently and a lot of what they're doing, we've been looking at a lot in 2 ways. One being able to deploy into it and scale out into it. Obviously, we already support running on that stack, so you know, people can use it. But no, there's no other like native integrations yet. They're still coming, all like kind of on the platform list. But what we're working on right now is the vCloud integration, and a lot of additional VMware kind of stuff is coming out of that because we have 2 partners in Europe that are wanting to integrate this with their vCloud. So they, you know, they host public cloud, private/public cloud, and they want to allow people to automatically, you know, tick a box and say, well, I want a WAF, and you know, we'll automatically deploy this and so on. So a lot of kind of integration there. Yeah, there's Grafana, more Tanzu. Well, you know, we got to balance it out.
You can
But
guess
yeah.
who Christopher works for, can't you?
Yeah, well, I mean, I can guess, and that's super interesting
Yeah,
because I mean, like, so to give you an idea, Christopher,
it's all good.
65% of our clients run on VMware. It's by far the biggest infrastructure provider for us, by far. After that comes AWS and then DigitalOcean. So VMware is a big deal for us, and with Snapt, Aria, our traditional product, we're VMware partners, all that kind of stuff. So now Nova is listed on the VMware Marketplace. It's going through currently VMware certification. So, you know, all that kind of stuff is on the list. But yeah, you know, any VMware feedback you have is valuable feedback because literally more than half of our clients run on VMware.
Right. Well, I just taking a look at the time. We've got 5 minutes left on this, so you probably want to.
Yeah, I'm basically done. The only thing I wanted to say is literally on the front page there's a register button and people can get there and try it for free. And then anyone who likes, anyone in this call, we can give NFR code so you can have the whole thing free, whatever. You know, I put my email there. It's dave@snapt.net, because if anybody wants to chat, give feedback, ask questions, complain about something, like the opportunity to speak to people like yourselves that, you know, we can get kind of candid with is pretty cool. So please don't be shy.
Sure. Okay. Well, thanks. That's great. I'm going to unmute everyone for the last 5 minutes of this, then, and we can just have a kind of a free-for-all chat. And then I guess at 1:45 we'll take 15 minutes off before Saslo is going to come on and talk about Datrium. So thanks a lot. Thanks a lot, Dave. I will unmute everyone, and then, you know, if you can go nuts with your questions without me having to read them out for you.
And me trying to read them awkwardly.
All good. Everyone's.
If I could begin quickly, I asked about the dashboard, which you showed. Do you also do analysis for, like, do you show a dashboard to your clients of, say, your analysis of your global footprint, in terms of if are you capturing data from your other clients? And I'm not saying you'd share their particular data, but you might give sort of a heat map of what's happening around the world.
Yeah, we're working on it. There's a combination of things. The first thing is that we need a certain number of clients in order to do a certain amount of things. So, for example, as of recently, we've started to have enough nodes that we can actually do some pretty cool things, like, for example, shared DOS information. So already the denial of service monitors and stuff will actually use information from multiple accounts where it's possible to, but we haven't done any kind of dashboarding or analytics or intelligence stuff yet around it because like about 2 months ago this was 200, right? So
Okay.
It's coming, but yeah, it's a cool idea because there's a lot of stuff you can see. Like it's super useful to know that the network latency that we're seeing on your systems in your Asia data center, we're also seeing on every other client in the Asia data center. That gives you a lot of information.
Yeah. That's the idea. Yeah.
Okay, well, all right. I think that's it. I think if everyone's done with all their questions or anything, I think everyone's still typing in chat a bit there. But yeah, I'll get the information pack out to everyone with a kind of an overview of all this. Dave, you said you could have the slides available to everyone as well. That's no problem. And
Yeah,
I'll also send out the information on the community edition so everyone can have that as well and mess around with that.
Well, I'll just, we have like an NFR code, so I'll actually just give that to you and then you can send it to the guys so they don't have to, please feel free to contact me, but we'll send out that code where you can just sign up and get everything.
All right. Sure, great stuff. Well, I'm going to keep the channel open, guys. You're more than welcome to hang on here, and then in 15 minutes we'll start off with Sazala, who is already in the channel. He's nice and early, finished up that last presentation. All right, great.
Thanks, Dave.
Thanks, Dave. Awesome.
Thank you. Thanks, everyone.
Yeah, brilliant.
Hey, Patrick. This is Sazala here from Datrium.
Hi. How's it going?
So I'm in California right now.
Mm-hmm.
And along with me, I'll have a couple of folks from California as well. Simon Long, looks like everybody knows him.
Yep.
Popular. And I was saying he was banished from UK, he came here.
Yep.
And then there's going to be Mike McLaughlin, who will also join us from Tech Marketing. Okay. And we have Stuart who's part of the Datrium team, but he's in UK.
Yeah,
so
we know Stuart as well.
I'll be presenting, and then some of my team members can jump in with the questions if there's any questions, kind of things like that. And I will be doing some slides and then the demo. I'll kind of switch between both of them. So I'll show some slides, just kind of set the context of what we do and what are we offering, and then switch to the web browser to show a demo and kind of switch back and forth.
Sure, no problem at all. That's all good. Like I said, you've got till 4 o'clock. I know Christopher has to jump off at 4, but everyone else is welcome to stay on for a bit. And I will, afterwards, I'll do the chair giveaway thing. But yeah, okay, so the floor is yours. And we will proceed.
Okay, I'll kick it off. Hey, hello everybody. My name is Sazala Reddy. I'm the CTO, co-founder of Datrium. And thanks for joining us today. I saw some of the the folks here, the websites and stuff. Pretty cool. You guys do a lot of good work. And I wanted to kind of make it a little bit more technical if it's possible, but I do want to show at the high level slides, like what are we doing and what problem are we trying to solve. So before Datrium, I was to be the CTO of Data Domain. It's a fantastic product, but it's been 20 years, right? So it's time to change the landscape. The first thing is that if you look at the industry today, no business can be down anymore. Everybody wants to make sure that their uptime are going to be up. Every business depends on it. So DR become critical for every business, disaster recovery. But if you ask any customer now, what is the top reason why they're having disaster events, it's the ransomware. And most people don't talk about it because they're not allowed to for some reason, or nobody wants to really say that they were attacked by ransomware unless they're a public institution. And there are other reasons as well for disaster recovery, which is power outages and all the other stuff you have, natural disasters. And but the ransomware is the number one. So I've studied the ransomware quite a bit. We've done quite a bit of webinars on ransomware. It's a deeper topic, so I probably won't go into the deeper stuff here. But one thing to realize is that a lot of people are depending on backups. to recover from disasters. But backup is no longer sufficient. You need quick recovery, because if it takes too long for you to recover from your backups, because backup is not built for recovery, backup is built for backup. And if it takes too long, if it takes 2 days to recover, then you're better off just paying the ransom and moving on. Otherwise, that's what the ransomware people are banking on, that it takes too long, you can just pay up. So if you study the DR, now not everybody is familiar with the disaster recovery problem. So I just want to give a little context on the problem, how challenging it is. It's always been very expensive and very complex. If you ask any IT professional, like what are the things they want from a disaster recovery solution, they'll all say the same following 3-4 things. Number one is RTO. When there's a disaster, could be ransomware, could be power outage, everybody's watching you and everybody wants things to be back up and running. So RTO is the number one thing everybody cares about. Like, how quickly can I come back online? And then number two is ransomware recovery. Like, if I get hit by ransomware, how quickly can I recover from this? And there's the ease of use. DR is very complex. How easy can it be for me to use, especially in a disaster recovery solution situation? If it's very, very complicated, it's going to be very scary for people. So the reason it's been super challenging and complex and expensive is because if you look at a data center, you have one data center, and then you end up having a second data center. And on data center one, you have applications, hypervisor, servers, networking, primary storage, backup. You have all these components, and you try to replicate the same hardware on the other side. And when there is a disaster, you try to fail over to the other one. It is non-trivial to map up all these things into the other place, because it's Murphy's law, things will go wrong. And then there is the runbooks, which tend to be, the moment you make runbooks, disaster recovery runbooks, the moment you make them, they go out of scope, and they're very hard to really make sure that it's going to work for you. So I've never met a customer who said they have an awesome DR strategy. And if you have one, please let me know. I'd like to talk to that person. In fact, I had a customer who once told me he hopes there isn't a disaster, but if there is one, he prays he dies in it, because he doesn't want to deal with it. So we saw the industry, and we looked at all the various vendors in this space, and especially a lot of backup vendors are trying to talk about DR. So we said, okay, here's how the landscape is playing out. And like I said, I was the CTO of Data Domain. I built it. It's a very good product, but see, ultimately, all backup systems are called. The reason they're called backup systems is because they're good at backup. They're getting better, and they're getting better, and they're getting easier to use. There's now SaaS-based backup software, which is super awesome. The UI looks cool, but ultimately, it's backup. When you have a problem, what do you do with this backup? It becomes useless, because ultimately, what you really need is a way to recover fast. You need backups because for ransomware, you got to go back in time. But to really recover, you need to think about it differently. So this is showing you the two axes is ease of use. Yeah, as we go forward in our future, it'll become easier and easier to do backups. But ultimately, disaster recovery, to recover, the speed of data center recovery is what really matters. So what we have done as a team, we kind of got together. There are 5 founders. We come from different backgrounds. From the 2 of our founders come from VMware. They were the first engineers who built hypervisor at VMware, and 3 of us come from data domain background. So we took this idea that, okay, let's convert this complex DR and backup process into a simple to use SaaS solution. And I'll show you how that looks like, and following that with the demo. So at a high level, this is what we're offering. We're offering on-demand DR with VMware Cloud on AWS. What we're saying is that if you have any storage system on-prem or in the on the cloud, if you have VMware running your workloads, we will be able to provide you backup to the cloud, and we will be able to do DR to VMware Cloud on AWS. So I want to show you the components of our system, and kind of I also have a couple of animations to kind of walk you through how this works. So these are our components. So in Amazon, the purple hexagon in between the brass, that's our software offering. It's a SaaS offering, and it uses S3 as a backing store and then dedupe and everything else. So the idea is that you log into this global portal, you download this lightweight DRaaS Connect, that the smaller hexagon, into your data center. Could be on the cloud, could be on-prem, and you can have any storage system you want, like in SAN, NAS, HCI, it doesn't matter, as long as it's VMware. And then you set up these global backup and DR policies, runbook policies in our SaaS UI. And then you can start backing up data. We'll store the data on S3 in a dedupe format. It's super cost effective. And then when there is a need to failover, we will use VMware Cloud and SDDC. A couple of animations to kind of make it easy to understand what we're trying to do. So in steady state, imagine you set up your backups and you're backing up to the cloud. It's all great. So the costs, it tends to be super low cost because we use S3 and because we do dedupe on the cloud. And so in steady state, there's nothing much to do just other than setting up your policies to back up. So imagine you had a failure, could be ransomware problem, could be just a temporary power outage, whatever the problems are. You push a button on our UI with the runbooks, we will fail over to VMware SDDC in the cloud, and we're not copying data. So unlike backup systems which copy data from one place to the other primary storage, we worked with VMware for 2 years to get this live mount. Basically, we become an NFS data store. That live mount is basically nothing but an NFS data store. Our software is able to turn backups into live VMs instantaneously. And we do it through this NFS data store access through VMware SDDC. And then we would register the VMs, run the runbooks so that it comes up in the proper order what the runbook says, and bring up the VMs at that instant. It's zero copy, no reiteration, and we become from a backup vendor to a primary storage vendor at the click of a button. So you run so let's say for a couple of days you're running in the cloud because your data center is not fixed yet, and eventually your data center, it comes back online, the power outage went away, whatever the issue was. At that point, you click a button, say, look, I want to fail back. So we bring back only the changes which changed. If you imagine you have 100 terabytes of data, or maybe a petabyte of data, whatever that data is on the other side, and imagine in 2 days, only 1 terabyte changed. We only bring back the 1 terabyte changed back to your on-prem. And then we will shut down the VMware Cloud SDDC. So that way, think of it as you're paying for insurance after you have an accident. So then what you get is low cost backups in steady state. And when you have a disaster, you can bring up this SDDC, run your workloads, and then you only pay for them when you need to. Otherwise, you don't have to pay for it. So let me stop here for a second, and I'm going to switch to the demo and show you how this looks like and come back to the slides. So there's some questions here. Let me see if they're being answered by, Simon is taking a look at the questions. Okay, who pays for the VMC on AWS while it's up? So we are an MSP. So to get this live mount feature from VMware, we decided to kind of work with them to be an MSP. So the MSP, the reason we do it is the simplicity for the customer. You get one bill from us for your Amazon, Datrium, and VMware, all services. It's a one SaaS service. So you get one bill from us, and we will make sure that we are the, that we pay for it. So because it becomes easy. We're not trying to make money on VMC. That's not our goal. Our goal is to pass through. We'll pass it back to VMware, but we just want to make it easy for the customer to actually experience the simplicity of it. Okay, now I'll switch to the demo. Hope you can see my screen.
Yes.
Okay, awesome. Okay, so here's our global dashboard, which I was talking about. This is our SaaS portal. This is our DRaaS offering in the cloud. So this is showing you the bubbles. I'll show what the bubbles mean. This is the central bubble here is our DRaaS offering in the cloud. It's basically for backing up data, storing the backups in the cloud. These are different physical sites you have, and they're all doing backups to the cloud. And this is the VMware SDDC, which is connected to our DRaaS offering. And you can have hundreds of these physical sites, and it'll show you all these bubbles in these 100 different sites. And these could be any storage system you have, as long as it's VMware, it's all good. So I'll come back to this demo in more detail, but what I want to show you is the failover first and then go from there. But before that, one of the things we have done is that, you know, especially in a disaster recovery scenario, do you really want to learn something new? So we didn't want the people to have to really learn and read Amazon documents. So we, in fact, made even the vCenter for the SDDC like a button in our UI so that you can just launch it from here. And you see the vCenter from in the VMware cloud, and it looks the same on-prem. The way I can tell the difference sometimes when I play with this, and then I'm confused that this logo is blue in the cloud and the logo is green on-prem. So I'm going to be kind of doing a quick failover to show you how does it work. So if you look at the data stores, you'll see that there is vSAN data store, there's other data stores, but these 3 data stores are Datrium data stores. This is NFS mounted. So this is what we worked with VMware for 3 years. We're the only vendor in the cloud, like a SaaS vendor, to have this capability to work with VMware. And I will be showing you I'll be showing you how the failover works, okay? So then come back to, so I'll pick an example. I already made a DR plan. I'll walk through the DR plan later, how that looks like. But what I want to do is show you how actually we can failover our test. So there are 2 options. When you can failover, other one is you can create a test bubble and run your workloads there. So the first thing when you do this is we ask you which backups you want to pick, because if you have a ransomware attack, you don't know which point in time you want to go back in. Like if you have a regular disaster, you probably want to go back to the latest backup. But if you have a ransomware attack, you don't know. You have to try experiments. You know, in this case, it's a small set of VMs, but you could have hundreds or thousands of VMs. You can go back and pick whichever one snapshot you want. It could be days, it could be weeks, or months old.
So I've just seen in chat a couple of questions. Barry, I'm not sure whether we got to yours or not. He said probably missed. Do we have to be using your primary storage?
No. So you can use both. We do sell a primary storage on-prem. It's like a HCI product, but you don't have to. You could use any storage you have as long as it's under VMware. That's the new thing we have invented, is a DRaaS Connect, that you can just plug in that into a vCenter and we can back up anybody's storage system.
Okay, and the only other one which was on here as well was Gareth's, which said, do you get those VMC credentials prior to a failover, or are they automated and sent back to you when you initiate failover?
I can answer that one. The VMC credentials basically become available to you in the control shift user interface once the SCDC is deployed. When you go to the failover SCDC option, there's a little open vCenter button, and there's also show VMC vCenter credentials, and it gives you the cloud admin password there.
Yeah, I'll show you that in a minute.
Mm-hmm.
Okay, so this is I think if you have probably used SRM, Site Recovery Manager from VMware, I think one difference is that, you know, it doesn't give you options to go back in time. So that's the one difference here, that we can give you the option to go back in time. There's a bunch of options. I won't go through all of them. So here there's a preview showing all the steps, and I'll get this runbook stuff later, but it's kind of showing you all the steps. You can have lots of steps here. You can have 50 different steps. You can say pause here, do this, bring up these VMs first, and the next VM next. Like for example, bring up my DNS, bring up my SQL servers next, and bring up my application servers next. You can have a lot of steps. This is a very simple one. And so what we do is that we go, so this is our UI. We show you all the steps we are doing. We prepare the VMs. We change IP addresses if they needed to be changed. We prepare all these VMs and we register the VMs, and then we power them on into vCenter. So I will show you how this is looking on the vCenter side as well. So you can see some of the actions will show up pretty soon. And you will see this the VMs being registered on this side and powering on. I'm gonna switch back and forth. Hopefully people don't feel dizzy. Okay, they're being registered. Yeah, so they're registered here. They're powered off right now because they're registered. They're powered off, and then they'll power on in a couple of seconds. So this is a big deal because, you know, instead of having to copy data from the backup system into the, you know, into the SDDC, it'll take a long time, because if you have 100 VMs, 100 terabytes, it'll take you like almost a day to copy all the data to that SDDC. So because we're not copying any data, we're just registering and powering on, you're good to go. And so in this case, the most of the time taken for us to register and power on is mostly the vCenter time it takes to register and power on. There's some finite time it takes. And if you have 100 VMs, it should be the same, kind of roughly the same amount of time it takes to power on. So at this point, they're all powering on. So these two are powered on, and this will power on pretty soon. And you know, in this case, we're doing testing, so you can just go and check all these VMs, make sure that they're all looking good, and you can say, okay, look, it's all good. And these probably, okay, I think it's done. So these two VMs are powered off because they were powered off in the original system, and then there was an option to say, okay, let's power them on as well, but we didn't pick that option. So you can have whatever you have in your data center will reflect in this data center as well. So then and then when you're done with your testing, you can say, look, or my failover, whatever you're done, you can say, look, I'm done. Let me then clean up, because it's basically what cleanup does is that it does the reverse of what the failover did. It'll just clean up everything on the other side. It'll power off the VMs and unregister and bring it back to the clean state where it was before. So then you can basically shut off your SDDC if you wanted to. So we're back to where we were before, and then all good. We tested everything. And as part of the system audit reports, because from a DR perspective, a lot of people need compliance reports because it's a business continuity, and especially bigger companies need a compliance audit history of what all happened. So we keep track of all the things you've done so that you can go back in time and you could look at the audit history, and we keep detailed reports of everything. There's infinite history, so that you can show it to your, the audit reporters, or you can keep track of it yourself. So here's an example of the audit report we generate for this case, what we did. So it's showing you all the things, the plan summary was, all the runbook details you set up, and it shows you all the steps we have taken to fail over. Everything is green right now, but if something was broken, it will show up as red, so you can go fix it. So this is something which is built into the system. So let me pause here and look at some of the questions. Yeah, is there infinite limit? Yeah, then there's an infinite limit to, there is no limit to our audit reports. So far, nobody's hit it, and it's always going to be there. Hey, Simon, do you want to answer some of the VLAN questions?
Yeah, I was just trying to respond to Gareth. Gareth, can you just expand on exactly what you mean? Because I'm just reading through it and it's early here. I'm not even one coffee in yet. Just can you clarify what you mean by like the VLANs and networking? Do you mean like once the VMs are up and in the SDDC?
Yeah, yes. So once they're up in the SDDC, it's like that. You've had a failure of one data center, and you've got two others like you saw in your little plan there. And how do you guys then kind of deliver that piece? It's just trying to build up that whole picture. Do you deploy just your connector, or is there other additional things within, say, like VMware that you need to deploy to do this?
Yeah. So the connector itself will just manage this kind of snap and replication of your data. Once the VMs are running in the SDDC, if you want to have communication between other on-premises environments or have your users access the workloads in the cloud, you'll still need to either configure things like a layer 2 VPN or an IPsec VPN or an AWS Direct Connect or your own VPN solution, for example. So the similar options to would be if you were a native VMC customer. We don't have anything at the in our product that will enable that any better than what's already out there available.
It's just understanding that from the orchestration point of view. You guys seem to be ticking pretty much most of the boxes. It's just, do you need that last final bit?
So yes and no. I mean, it obviously depends on the customer and what they have in their environment. One of the things that we see happening most often is using like a VPN appliance, such as like a Palo Alto or an OpenSec VPN, which is like a virtual VM, sorry, virtual VM, just a virtual machine that you can actually fail over, pre-configure and fail over as part of your disaster recovery plan that gets brought up first. And then, for example, if you have users that were in your office, you're now sending them home because the office is closed, you can then bring up that VPN appliance in your cloud and then have the users connect to that new IP address in the VMC instance. So that's something that we're seeing a lot of benefit from for the customers that only have one site, and basically when that site's gone, they have nothing else. If you have multiple sites, then yeah, you might already have a direct connect plate maybe in place, or different type of connectivity options available. So yeah.
No, that's cool. That helps out. It's just trying to see how this all fits in, really.
Yeah.
Cool.
Okay, a couple of questions.
Yeah, a couple
I'll
more.
take the first. Yeah. So let me see the first. It says, are all these features available, or are they different tiers? So the backup, I think. So no, there are there are multiple options. One is that you can choose all the things I just showed you. You can have that. We also have an option to do DR prem to prem. In that case, you're not using our backup software. You're just using our DR orchestration software to manage your prem to prem DR if you want that way. So there are two options there. And also, by the way, you can just use it as backup. You don't have to do failover to the VMware cloud, but I don't know what the value of that is, but that's another option. Okay, what are the benefits of our VMware offerings in this space? Because, okay, let me talk about that a bit. So if you can definitely use VMware, SRM and vSphere replication and HCX to do replication to the cloud just by itself, and then do the failover. I'll tell you what the two problems are. And one problem is that if you have lots of servers and SDDC running all the time, it's very expensive. You can pay for it if you want to, but then the DR side becomes more expensive than your main data center. I think I have a tough time go through the CFO. That's one issue. And second issue is that you can't have a small setup, because if you have 100 terabytes of data, because of HCI, how HCI works and hyperconverged works is that if you need more storage, you need more servers. So a two-node system won't be enough to store all your data in steady state. So you need to have like 10 servers if you have 100 terabytes or more. So that's going to be expensive.
Sorry, can I just interrupt?
Yes.
Elastic vSAN allows me to have 2 nodes online with all of my data, and then scale out afterwards. So
Elastic vSAN also has a limit, because if you look at each node can only have that much of storage. It is not infinite storage. So you do have to scale your servers as you add more capacity.
Okay.
So that's fundamentally also at a really small scale, like 2 nodes. And the Elastic vSAN, actually, it is not cost effective, by the way. Elastic vSAN becomes more cheaper as you get bigger and bigger systems. But still, having it all running all the time, there is a 10x difference between the price, between what we offer and what that can offer. So price does matter. At 10x, it does matter. I mean, nothing wrong with VMware. I mean, that's just a math of what the offering is. So, and then the other problem is that if you have ransomware attacks, you need to have backups. So there is no backups built in to this with the VMware of like the HCX and the SRM. And so you're going to be missing out on that particular feature. So then you have to get a separate backup product to do backup to the cloud. So now you end up having to pay for a lot of components to actually make it work. Okay. Does the solution work with only on-prem solution? Yeah, we can do 2 private data centers, but in that case, you would need to buy our primary storage to do prem-to-prem failover. Okay, anything else? Okay. I was actually going to make some slides on why. So there are multiple options one can do. You can choose VMware, just by VMware itself, and you can choose other backup vendors. Actually, I was going to make some slides, but I thought that was too detailed for this audience, so I kind of skipped it. Maybe next time I'll show you what the different options are for people and what the challenges are. The 3 things people care about, again, like I said, is RTO, which VMware does provide, but the cost matters and the backup matters. So you need all these 3 things. You need backups, you need RTO, and you need and then you need the simplicity and runbooks and everything else. Okay. So now let me switch over to my slides, and I'll come back to this and show you how the whole thing actually operates, how easy to set up and everything else. Okay, so here we were. So what I showed you was our kind of just failover from this our backups into the VMC SDDC. Okay, so to do this well, our software needs to have the convergence of 3 technologies. You need to have backup software at the foundation of it. You need to have technology which can make your backup software become primary storage when you need to. And you need the orchestration runbooks to make it all stitched together. So it took us 5 years to build this, because if you look at any company works on either they work on backup or they work on primary storage, but never all of them. So we spent a lot of time making our file system be cheap and deep when needed with low-cost backups, and then turn our backups into like a live data store when we wanted to. So that's the advantage what we're offering to customers, is that without having to pay extra, and you get instant RTO, and you get this live mount access, and it's not a toy, not for a couple of VMs, it's like built for thousands of VMs. And the runbooks really stitch it all together and to bring it up when you actually have the problem. Okay. So the ransomware attack, this is a really interesting problem, because a lot of our customers are getting hit by ransomware attacks, and we help them a lot, and they call us and we kind of walk through them to what to do. But generally the idea is that, okay, here, if you get a ransomware attack, you can start in a clean state in the cloud. That's what we're saying, that, okay, if you get hit by ransomware attack, you don't know what's compromised, you don't know what networking you have. So we're saying, okay, here, push a button, start cleaning the cloud, and then we can then figure out what the next stages things to do are. So the thing with the ransomware is that you have to go back in time. So you do not know whether it attacked you at Sunday 1 p.m., Sunday 12 p.m., Sunday like at 9 a.m. And we have some techniques in our system to tell you like how the data changed. But otherwise, but still a guess. Nobody can really detect ransomware like when it hit you. So you have to try experiments. It's like a binary search. You may have to bring up your workloads from 9 a.m. Does it look good? Okay, no, doesn't look good. Okay. Try it at 8 a.m. Does it look good? Okay, maybe that looks good. So to try experiments like this fast, you need something like this so you can push a button, bring up all your workloads, and see if they look good. So that's what we're offering, that you can do rapid iteration on this stuff. So there are 3 things people care about when generally in any software, right? For what is the day 1 operations, what is day 2, and what is the day n? So the day 1 operations are pretty straightforward. I'm going to show you in the demo as well. You have to identify what sites you want to protect. You set up your backup policies, and you set up your runbooks. It's pretty straightforward. It's not very complicated. In day 2 operations, because we are a SaaS software, there's really nothing to do, because we have done full software upgrades. It's fully automated. There's nothing for the customer to download and apply patches. It's all done automatically, like how the SaaS software is supposed to be. It's over-the-air updates. And we use Lambda functions in AWS to kind of do self-healing and fix itself if there's a problem. Because in Amazon, things do go down, and things the SLAs are not super high. So we have a way to kind of fix ourselves when there's a problem. And we do compliance checks, and I'll show you that in a minute what that means. So, and then when you have a problem and someday in the day n, you have your vCenter, you push failover, and you bring up your workloads in the cloud, which is kind of what I showed you just now. And this is what I mean by the compliance testing. That one of the problems with runbooks is that when you set up a runbook, you don't know if it's going to work for you when you actually need it, because there's going to be config drift, things have changed, whatever. So what we have done is that we have done this compliance checking every 30 minutes to make sure that your runbooks are in compliance with what you said you want it to be. And we will warn you if there's a config drift. So this is super important, because this is what gives you confidence that when there is a DR disaster, when you push a button, it'll all work for you, and you don't have to really fear that the config has changed and it's not going to work for you. Now, I'll show this one thing, and I'll switch over to the demo as well. So let's see. A couple of questions before I go there. How small does the scale? You can start really small. You can start with 1 terabyte if you wanted to, I guess. And you can start with 1 VM if you wanted to. There is no limit to the size. There's a max size for sure, and it's thousands of VMs, but there is no small size. You can start with 1 VM if you wanted to. I mean, it'll cost you money because there's a minimum set of charges to do. Okay, so here's an example of a customer, like where we were helping them. So they were considering alternatives, like they were considering running Nutanix and Cohesity for their backup. I mean, nothing wrong with these products. They're just the way they are. And they were going to use Cohesity to back up to the cloud and they're going to dump data into S3. The problem was that they had two problems. One is that if you have a failover, this is a petabyte scale customer. If you have a disaster and you want to failover to the cloud, it'll take you 22 days. It's just physics. You have to copy all the data from S3 and then copy it into into EBS and then convert them into Amazon VMs. That itself is that's a separate problem that you're converting VMs. The challenge is that just 22 days. No customer can afford 22 days of rehydration. And so they chose Datrium because of simplicity. You just saw the UI. It's pretty simple to use, super easy to learn. And we provide this VMware cloud integration. There is a...
Yes, you see Barry has a question. How small does the scale? What's starting
I think
point?
I just talked about it just now. I said,
okay. Yeah, sorry, you might not.
I hope people could hear me. I said you can start with 1 VM if you wanted to.
Yeah, no worries. I just saw it pop up and I was like, did we answer that?
Yeah. So Barry was good, right?
Yeah, we're all good. Sorry, I had to unmute.
Okay. So let me switch over into the demo and show you the 3 things I talked about, the 3 setup things. So the first thing you have to do is, you have to identify what sites you want to protect. So we do sell a primary storage system, and it's a high performance primary storage system, but you don't have to buy that. You can also have your own primary storage, whatever you have, Pure, Nimble, whatever you want to do. So so what you have to do if you're going to set up a site is, because there are a couple of slides here. You first have to download our connector, and this is a lightweight VM, and you plug into your vCenter. It's pretty straightforward. I won't go through all the details here, but it's a pretty straightforward lightweight VM. And then you register the vCenter with us, and then identify which backup target. In this case, the cloud backup is what you want to target as. And you set up some backup policies, and I'll show you how the backup policies look like. So you can say, look, I'm going to do my gold SQL policy, and then you could choose to do pattern matching things, saying, okay, all my VMs which match this pattern are going to be in this policy, and we'll back them up. And my schedule could be, hey, it's a daily backup. I can keep them for a whole 1 year, and then I can say, take every 4-hour backups and then keep them for maybe 4 months, something like that. You can choose as many schedules as you want so that you can have retention policies for years or months or days you wanted to do. So once you set up your backup policies, that's it. You set up your backup policies, are done. And then you have to set up your DR policies. So I'll show you how the DR policies look like. There's a question here before I do that. Let me see the question. Control Shift admin. Yeah. Our Control Shift is a SaaS offering. Yeah, it's an Amazon. One more question. So I'll show you that was an easy way to just set up a site, set up backup policies. You can probably do that in 10 minutes. And then let me show you the runbook, how the runbook looks like. So the runbook gives you many different options. The first thing is that, hey, you can do prem, like in here, prem to prem. You can do prem to the cloud, and you can do different topologies if you wanted to. In this case, I'm going to show you the prem to the cloud, what I just showed you as a failover experiment. And you pick what sites you need to failover from. And then here's the one which showing you what are the backup groups you want to do. Like in this case, I only picked SQL as my backup policy groups. But I could have chosen 5 different backup policies, and each one could have hundreds of VMs. And then you can group them all into one DR policy. And then some of these things are other things are like standard SRM kind of type of things you have to do, like set up data store mappings, vCenter mappings, folder mappings, and also the important thing is networking. How do you want the networking to be when you fail over? And if you want your IP addresses to be changed when you fail over to the other site, and when you have a test bubble, are there different IP addresses and things like that? You can leave all the default ones to be the way it is to simplify. but if you have extra needs, you can always configure them. This is a way to do script VM. Like in some cases, customers, like for example, databases specifically, they want to test that the database is in good state. So you can run some scripts to make sure that the database is all good or database is up and running before you do the next steps. And lastly, this is showing you the steps you can do. So if you want to, like I mentioned before, if you want to order your runbook so that you bring up certain VMs first and then certain different VMs for next. So you could also do other steps like, I want to like power on all the VMs, don't power on, or you can add action steps like run scripts, or wait for somebody to say yes and no, and like all those kind of. There are a lot of options here for the fancy. If somebody wants to really go fancy on it, but otherwise the most default options is what I'm thinking everybody will probably use. It's very simple to set up. You can set it up in like 10 minutes, 5 minutes. So once you're done with this runbook, this is the one I showed you where we kind of did a failover. One of the things we do is we do this compliance checking, which is what I talked about. This compliance checking is done every half an hour, and it checks like about a couple of dozen checks it does, so that we always make sure that your plan is all good and working and is never out of compliance. Those were basically the three things I talked about was set up your site, set up your backup policies, and set up your DR plan. That's it. There's nothing more to do. Everything else is done automatically by the system. There are a lot of questions now. I don't know what I said, but there are a lot of questions I hear. Yes, so the day two operations are, there's nothing to do. We will completely monitor, we'll monitor, we will fix it, we will upgrade, and we will do everything for the customer. Can you replicate continuously or only get a set of snapshot schedules? So currently we use VMware snapshots, the VADP based backups, and we are working on a continuous data protection as well. So maybe by the end of the year, maybe in a few months, you'll see something maybe a little bit more in that direction. But right now we use VMware snapshots. Okay, once I failed over to VMware on AWS, are my workloads automatically protected somewhere else? Yeah, so once you fail over to the VMware Cloud SDDC, we will make sure that those data is backed up in our cloud, our DRaaS offering as well. So that basically we don't do it too often, but when you actually make sure that when you actually fail back, we will make sure that all the backups are stored correctly, and then you can fail back. Okay. What was the question? If a customer fails over due to DR, can they decide to stay in the cloud? Yes. So let me show you in 1 second what that means. Okay, let me go back to this picture. Yeah, so in this picture here, what you're saying is that, hey, if I failed over, can I just stay here? Yes and no. So like this is the top picture is what you're asking about. Can we protect the data in the workloads running in just the VMware Cloud itself? So we don't have a DRaaS Connect yet for this thing. It's coming by the end of this quarter, that we will be able to protect your workloads running in Amazon as well. Then once you do that, then you can stay there forever. In fact, a lot of our customers are asking for that, because right now, if you run your workloads in VMware Cloud on AWS, they don't have an easy backup and DR path in the cloud itself. So we're going to offer that by the end of this quarter. And that way you can be able to run there forever. So that is actually our plan.
To make sure I understand, when customers are failing over to your DR as a service offering, is that into your VMware on AWS tenant, or is it the customer's own? And once they are there, can they stay? I mean, if it's mine, I can obviously stay there. If it's yours, then I didn't know if you allowed the customer to stay there in production.
They can stay there as long as they want. Okay. It's our tenant in the sense that it's our contract, so we are the ones who own it. But they can check. But we don't charge extra for this VMware Cloud. We don't. It's like a pass through for us. We don't want to make money on that. Our money is made on our software, and we don't charge extra for this, so the customer can stay as long as they want. What I was saying was that if you stay here, if you stay here forever,
of course,
the one problem is Yes, exactly. So we are working on this DRaaS Connect for our people staying in the cloud itself, and we'll have that by the end of the quarter. So then you'll have a full data protection suite. If you're going to run in VMware Cloud, you'll have backup and DR, on-demand DR for all the workloads in the cloud as well.
I'm assuming if they move it into your cloud, there's no tenancy there. All the VMs are next to each other. There could be noisy neighbors. There's no isolation.
Yeah, so we don't do like, it's not an iCloud where there's multi-tenancy like that. Even we provide a different set of resources for everybody. There is no shared, dedupe across them. There's no shared, like basically every customer gets their own set of things.
Okay, so you set up their own SDDC for every customer.
Yeah.
Yes.
Yeah, each customer have
their own
SDDC.
Yes.
Cool.
Because we're aiming for we're aiming for enterprise customers, and like people who have 1,000 VMs, 2,000 VMs, they don't want any of this kind of sharing of stuff.
It was just because you said into our cloud, I was concerned that you were sort of basically bringing all into one big SDDC. Yeah,
no, so what I meant was that we own the tenant, like in the sense that we own, like everything comes from us from a manageability perspective. Like customer doesn't have to go buy this separately for themselves and put it all together. No, we are saying you just come to us, one shot, we'll give you everything.
Yeah. Fabulous, thank you. Thanks for the clarification.
Hey, Zala, there was another question around if you're running in VMC on AWS, for example, as your primary, can you then use a secondary on-prem site as your disaster recovery site?
Yes, as soon as we have actually on-prem disaster recovery site. Not yet. We're working towards that. That question has not really come up yet for us, but we are working on a solution like that. We're calling it an edge solution, and we'll have that by the end of Q4. And then in that case, you can probably do that. Yes.
Yeah.
So somebody asked us before, does it have to run only on your primary storage? That's not true. So this is our primary storage, this DHCI thing. You don't have to buy this. You can have anything you want. This is, of course, you can buy this and it's really good, but you can also have other storage systems, no problem.
Yeah, Barry just asked, I assume you would recommend a separate backup product.
Why? Because we have built-in backup. You don't need a separate backup product. What we're saying is that we have combined backup and DR into one product. Because if you don't combine them, you will not get the RTO. If you have a separate backup product and a separate DR product, you're going to be spending a lot of money first, and then you won't be able to get the instant RTO like you need when you actually have it.
It was specifically around long-term archival and granular recovery, so being able to recover elements from SQL databases, Exchange databases, SharePoint, all those good things that you'd want from your backup tool. Do you offer those, or would you?
We do.
Right,
we offer SQL-based recovery tools, and we also offer single file guest restore, and we offer long-term retention. So we offer all the things you just mentioned, which then I think is kind of, are we 100% like what Commvault has? No, Commvault does a lot of things. For example, Commvault has been in the business for 20 years. They do physical sites. They do, IBM mainframes. We don't do any of that stuff. We focus on the most important things for now. I think over time, we will probably do more backup level, application level integration. But the common things we do, we have granular recovery. We have all those other cool, simple, cool stuff. Other question. Okay. So as I was showing you before, that it's a single point of billing and support. That in my demos you just saw, you have to learn nothing about Amazon, and that's really important because I didn't even leave my console or vCenter. That's important because when you have a disaster, it's a really challenging situation for a lot of people. They're under stress, and you have to start reading Amazon documents. It's kind of really complicated. So we just let people just use vCenter as a simple way to that. And then even we launched vCenter because It makes it super easy for the customer to like not having to learn something new when there is a problem. And one day we'll go to Azure, and then the customer doesn't care. It looks the same no matter where they go, because VMware is there and VMware is here. So, and then our software is there. So it look all the same no matter which cloud you go to. The true multi-cloud is that, right? That you get that experience that with VMware, that you don't have to learn a new cloud, you know, all the details of it. So it's also one support call. Like if you have a problem with anything, just call one call. It really matters to customers that they're not calling 3 people, and we will deal with all the issues. All they have to do is pick the SLAs and make the DR plans, and we're good to go. So the summary is that we are offering a global backup and DR strategy for every business. You could have a global business, it could be a small business, doesn't matter. We will help you centralize all your backup and DR in one place, have a simple UI, the one I just showed you, reduce CapEx, make it super cost effective because we are paying for VMware servers on demand, or generally any compute services on demand. It's fully automated. There is no software updates. There's no AMI to maintain. None of that stuff is done. We all do it with the day-to operations are 0, and we've offered this instant RTO to fight ransomware. So that's the end of kind of our presentation and the demo. And if there are any questions, I'm happy to take any questions and any feedback as well.
I think I'm getting through most of the questions on chat, but just let me know if I'm not. I'm a bit slow at typing this morning.
Oh, is it a bit early for you, is it, Simon? Is that
yeah, it's 7:45 right now. Yeah.
So yeah, guys, if you've got any other questions you want to bring up, anything for discussion, you feel free to unmute yourself. This is going to be the more free-for-all bit, I think.
Yeah.
As per the first slide, I was very keen about ransomware. So how did this application or your product will, know is there any ransomware attack, and how does it have been taken out from the, detecting the ransomware if the, VM have been encrypted, or if the VM have been, hacked or something. And then in case of that, as you mentioned about, the data recovery is based on the backup, wasn't it? So the only relying fact is to rely on the previous day backup, then you can restore it and secure your own infrastructure and tighten your security towards the network so that no one can enter into your network and then put a ransomware onto the product. So how does it deduct? So I'm a bit keen to know.
Yeah, so there is no perfect way to know when ransomware attacked you. There are some techniques, but it's all in some sense a guesswork a bit. It's a little bit of a detective work. So when the ransomware starts encrypting your stuff, the backup change rate does increase. That is a sign that maybe you got infected. It's not guaranteed. They may do it slowly. So that ransomware is becoming smarter and smarter. But it's a sign that when things change a lot in your backup stream, then that's a good sign that you have a ransomware problem. But you still can't tell whether it was done at 8 a.m. or was it 9 a.m. was it 10 p.m. You can't really know exactly. So you have to try experiments, and then you bring up a certain point in time, and you do have to copy some of the data out of those VMs into new VMs, depending on how we got attacked. We actually have a purple binder. We actually have a run book, like a real run book, not this run book I just showed you, but we have like a recipe, a document. I'm happy to forward that to you as well. It's a recipe on how to recover from these problems. It's a multi-step process. It's not a trivial thing. But what we are helping is that you can bring up your workloads without having to wait for a long time. And you have to bring up your workload. You have to try experiments. That is what we are really good at.
So on extending that, can I hook into the kind of restore process and do a AV scan or some kind of cleanup as I'm restoring? So let's say they fix I don't know, someone fixes it, and I can just hook in. Yeah, it's a good question.
Yeah, not today. I think we don't have a way to hook it. But you could clone the VMs and run an AV scanner on the VM if you want to. That's the option we provide, but we don't have a direct integration with AV scanner into our system yet.
Okay.
So is there any way that it can detect automatically and switch it onto the DR side from the previous backup kind of thing? Like
that's super hard, because how okay, ransomware detection is a really hard problem. So there are three things in ransomware: there's prevention, detection, and recovery. So detection is really hard. If anybody's telling you they can detect ransomware, like for sure, I think that's a little far-fetched. It's hard because you don't know, because we are a storage system. Unless we do extraordinary stuff, we don't know if customer turned on encryption. We don't know whether the customer data is really, something we can't read. I mean, how do you know that you got hit by ransomware unless there's a pop-up which says, okay, you're now encrypted. You're now under ransomware.
If we knew, we'd be very rich, Zala.
Yeah, I think so.
Yeah.
So by the way, ransomware is also become SaaS now. So ransomware is a service now. So it's there's innovation in that space happening very rapidly, and I've done a couple of webinars on that. It's actually a pretty interesting topic by itself. Okay, a couple of questions.
Oh, sorry. I was going to ask a question about the reporting. You guys say that you test it quite regularly. I know, again, most ISO auditors would love this. Can you get access to those reports saying that it spun up the VMs and these things were successful or not? Or is that something you've still got to go in and, as you said, manually test every so often? Or
okay, good question. So what we have done, because if we do testing all the time, like bring up VMs, we call it compliance checks, but it is not bringing up VMs. What we're doing is that every 30 minutes, we are checking to make sure that the plan itself is going to work for you. It is not bringing up the VMs. So bringing up the VMs costs money. And we have not automated that, but the customer has to push a button to say test failover so they can test it themselves. We have not automated that like to a degree where we just do it automatically for every quarter, but the customer has to push the button. We're afraid of doing automatically because it'll cost money to bring up all the VMs and bring up SDDC. So the customer has to choose to do the testing themselves.
cool, thanks.
Maybe it's a good idea. Maybe one day we could add that feature where you can say, okay, look, bring up my workloads every month.
Yeah, it's just, again, I know another vendor does that, and it's just one thing that some people have found quite unique in the market. But it's a different thing. You've got your own.
It's easy to, yeah,
it's easy to do, but it's a cost thing, isn't it? As you said.
Yeah, it's a cost thing. I think it's easy to do for us. I mean, we have all the techniques. We just have to set up a schedule saying, okay, test it every month, and then we can probably do it automatically. The problem is that people in the cloud, right? The bills show up, and then the cloud. If you talk to any customer who uses cloud, the surprise bills is what scares everybody.
Yeah, that's fair enough.
Yeah,
so
there's no reason why we couldn't automate that.
As part of our offering, we do offer 100 hours of free testing as part of our DRaaS offering with VMware Cloud. So you get 100 hours of free testing.
So I suppose you've got APIs that we could hook into and write our own kind of mini runbooks per se that could go off and test that anyway a month?
Yeah, you can just set up your, you could. Or you could just make the runbooks once in a while, in the beginning, and then you can just call this API to just say, okay, failover now.
Yeah.
Also, how's the data in regards with the cloud and the transferring in between the on-prem data center to the cloud? So does the data when it's transferring, does it all been encrypted in between both the sites? Or
yes. Yeah, of course. Yeah, it is encrypted, compressed, deduped, and all that stuff, and it's stored, deduped, and encrypted on S3 as well.
And the data, while it's been transferring over to the cloud, is it been also encrypted and then decrypted back and restore it as a machine?
When you have to, yes, that is true. So when they're encrypted in flight, encrypted at rest, but when they're running in the VMware SDDC, I guess, they have to be unencrypted to run on SDDC.
Okay, so in both the cases, between transit and the rest is all encrypted.
Yeah, of course, totally.
So when I mount those back in, do they like storage vMotion into the SDDC out of S3 afterwards, or do they stay in S3?
We have both options. Let's say you wanna just move to SDDC. We have in the I think I was showing you a little bit. There's an option there in our, when you fail over, that you can say stay in our S3 live mount, or you can just say, look, in the background, vMotion everything, storage vMotion everything into SDDC. We have both options. You can choose when you fail over.
Cool. Have you seen any kind of performance limitations in staying with S3, or have you done any testing and white papers on that?
Our software is, I don't have a picture here. I wish I could show you that. We have a unique software where, think of it as a scale-out hybrid storage system. We use S3 as our backing store, but we also have a scale-out architecture where we use EC2 on demand. We can scale it, and we use the instance flash on the EC2 to cache data. So it's like a hybrid nimble storage. You can think of that way, if you know what that, how nimble is, right? It's like hybrid storage array, but a scale out that we use S3 as our backing store. So as you get more performance, if you need more performance, you can scale out the compute with our instance flash. That way you get high performance. And it's the same system we sell on-prem, this DHCI. It's the same idea in the cloud. Our DHCI system is extremely high performance. We can do millions of IOPS. So
yeah, no, I saw it last year. I didn't see it here. I wondered whether you'd changed it, but no, that's fine.
No, Thanks. It's the same software running in the cloud. We use S3 as our backing store, and we use EC2 as our compute with instance flash as our caching.
Okay, yeah, it makes more sense now. So it's building like a virtual array in there and mounting it through and that sort of thing. Yeah, okay.
But we try to hide all this stuff from customer. They don't need to know. They don't know. They don't really care. They want to know that when they push a button, it works.
Yeah. I'm just technically inquisitive.
Yeah, good. Yeah, I think I should have put some slides like that. I should probably next time I can probably add those as well.
That's cool.
So that's our secret sauce, is that we are really good at making disks work well, or S3 is like disk in some sense. We might make that work well. How do you do high performance on S3? How do you do high performance on dedupe on S3? That's kind of what we're really good at, and that's our secret sauce.
Cool stuff.
Yeah.
So I think we're coming up to around time here. I do know that Christopher has a hard stop at 4. So I guess is there anything else that we need to go over on that, or is that pretty much it?
I was just going to say, in the marketing, the message from my point of view is a lot clearer than it was the last time I've met with you guys. So, really good job.
Thank you. I think selling on-prem primary storage is a hard sell because there's so many vendors. We found that our software works really well in the cloud, and and then we have this converged primary backup and DR. It's really very, very advantageous to have that pieces work in the cloud. So it's going to give us advantage. I believe we are 2 years ahead of everybody in this space. And working with VMware the last 2 years has really helped us propel into a new space. So thank you for the comment. I appreciate it.
And if you have any further questions as well, guys, feel free to just hit me up on Twitter or just DM me anytime. I'm more than happy to answer any additional questions if you have any.
It was really good questions. I appreciate it. It was really thoughtful and good questions.
Definitely.
Okay. Cool stuff. Okay, well, there we go. I think that's pretty much wrapped that up. Thank you very much, guys, for coming on super early California time. Obviously, Simon is slightly grumbling that he had to get up, I can imagine.
Definitely. No, not even slightly.
All right, just a bit. It's all right. Okay, we're going to hear the disdain in your voice. Don't worry, we'll make it an hour earlier next time. Okay, all right, guys. So that's pretty much it. Obviously, the one thing I have to do quickly is the chair giveaway. I'm giving away 2 Secret Lab chairs on the on my side of things. That's from both sponsors. Effectively, there's been a bit of a pull from their sponsorship of this. So I will go into my screen if I can, and here we go. Share that. There we go. If you can all see that, I've got a nice little wheel here, a sort of spin wheel. You see that?
Yeah.
There we go. So we're going from these are the chairs in questions. They look nice, don't they? Look, you can do Dota there, or what's this one? That's Overwatch, I think, or this one maybe. In your office, you can do all types of things with them. So there we go. So I am going to spin the wheel and see who is the first winner. Exciting. That's, oh, Ibrahim, there we go.
Yeah.
It looked like it was Jason, but it must be 1 pixel over. There we go. Okay, well, what I'll do is I will obviously hit you up, Ibrahim, in regards to how we can spec this up for you and send this out.
Cool. Thank you very much.
Yeah, I know. I looked at that and I was like, oh, it's going to land on the line and make it really awkward for me.
Well, you had to anyway, though.
Yeah. All right. I've got one more to do as well. So, winner number 2. You don't get 2 if it's you again, Ibrahim. We're not that generous. There you go. Oh. Jason won as well.
Well, that resolves the issue.
There we go.
There you go. That's fair enough, isn't it, Jason?
That's pretty good, right? Yeah.
Yeah.
There you go.
I was going to buy a Secret Labs Titan so I'm glad I didn't.
There we go. I can see Gareth gutted beyond belief. You have to, unfortunately, you have to get your own, mate. But
you have to save up, sell on the kids.
All right. Well, there you go. Okay, that's good. Like I said, everyone, feel free to please tweet about today and everything. I asked that if you feel ingratiated enough to do some sort of summary post on it, that would be great, because that helps us put more on, shows value for the sponsors like Datrium and Snapt, and also gives me an excuse to come on here and socialize with you all at a distance. And
can we share all the slides? Like, can you share all the slides so that we can go through?
So yeah, I mean, if Stuart or Simon or Sasla can hook me up with the slides, I will send out an email with all the information from all the various presentations we've had today, and then you'll have all that at the fingertips. And I will also put the separate videos online so that you can have access to those, the recordings as well.
Yeah, we'll sort that out. I'll share the slides. I'll take out some sensitive ones, which have other vendors' names on it, so that.
Yeah.
But otherwise I'll share later on. And also check out our website. We have cool videos on animation and all that stuff. Shows you what we do.
Great stuff. All right, cool. Well, that's brilliant. If anyone else has anything else to say, that's great. Otherwise, I'll call it day, and I will release you guys back to your normal working day for the next hour and a half or so.
It's Microsoft Build, so
yeah.
Oh yeah, it's
one conference to the next. But yeah, thanks very much. It was great. Good to hear from you all.
Thank you.
Cheers, mate.
Cool.
Have a good rest of the day.
Thanks.
Thanks, guys.
Bye.
Thank you very much. Nice seeing you all. Cheers. Bye.
Bye-bye.
Bye.